patterns observable in the environment can vary widely, depending on the scale and context. Such as natural patterns, these are patterns found in nature, such as the branching of trees, the symmetry of flowers, the ripples in water, or the formation of clouds. Patterns in the environment often emerge from the interactions of various elements and forces within ecosystems, geological processes, atmospheric dynamics, and human activities.
Fractal pattern is a never-ending pattern. It might seem so chaotic and arranged, but it is still considered as pattern. Patterns that are self-similar across different scales. They are created by repeating a simple processes over and over in an ongoing feedback loop. For example, branches of trees. Fractals. If you look at a tree, you will see a shape that looks like a Y. The simple shape repeats itself within a branch into another branch and into a full shape of a tree. Another example is a fern. The figure of the fern are constructed by repeating the same pattern at smaller and smaller scales. Another example is Romanesco broccoli. This displays its fractal-esque nature. Fractals show self-similarity or comparable structure regardless of scale. In other words, a small piece of broccoli, when viewed up close, looks the same as a larger chunk. Some of fractals examples are snowflake, camellia flower, and also the blood vessels.
Spiral patterns are fascinating and are found in many aspects of life, from nature to art and design. They are one of the nature's most common configuration. In mathematics, a spiral is a curve which emanates from a point, moving further as it 7/8 around the point. It's a subtype of world patterns, a broad group that includes concentric objects. Also, the spiral is an ancient symbol for growth and evolution and has a special aesthetic quality that resonates with humans, probably because of its affinity with nature. Ferns. The way a fern frond unfurls follows a spiral pattern known as alternate vernation. Sunflowers. The seeds in the center of a sunflower are arranged in a spiral pattern. This allows for the maximum number of seeds to fit into the space. Cracked tree stump. The spiral patterns you see in cracked tree stumps are likely due to the tree's growth process and its response to stress. The stress loading explanation states that spiral green trees flex more than straight green trees before they break. The spiral pattern of shells, such as those of snails or Nautilus, is often described as a logarithmic spiral. This pattern allows the shell to grow without changing its shapes.
Symmetric patterns refer to regular and balanced arrangements of elements, creating a sense of harmony and equilibrium. Symmetry involves the repetition of shapes, forms, or structures in a way that maintains a consistent relationship of proportion. There are various types of symmetry, including bilateral symmetry, meaning objects are identical on both sides when divided along a central axis. For example, butterfly. Butterflies typically have bilateral symmetry, meaning they can be divided into two identical halves along a central axis. Each wing mirrors the other, creating a balanced and visually appealing design. Another example is tulip flower. Tulip flowers often display bilateral symmetry, where the petals are arranged in a way that the flower can be divided into two symmetrical halves along a central axis. This symmetry enhances the beauty and elegance of tulips in the gardens and natural landscape. Leaf. Many leaves exhibit bilateral symmetry, dividing into two symmetrical halves. This symmetry assists in efficient resource distribution within the leaf and contributes to its overall structure. Watermelon. When you cut a watermelon into slices, each slice typically displays bilateral symmetry. The leaf and right sides are mirror image, contributing to the visual appeal of the fruit. And lastly is a zebra. A zebra's stripes often display bilateral symmetry, where the patterns on one side on the zebra's body mirror to those other side. This symmetry may serve several purposes, including camouflage in the grasslands and a potential cooling effect through the arrangements of black and white stripes.
In closing, the uniqueness of patterns in the environment serves as a testament to the inspiring complexity and beauty of the natural world. As we navigate through ecosystems teeming with life, geological wonders, and atmospheric marvels, we are constantly surrounded by an intricate tapestry of patterns that both captivate our senses and inspire our curiosity. That would be all, and thank you.